back to basics. From sustainable chemistry to quantum computing, Carolina undergraduates share their foundational research projects. By Megan Mendenhall. September 17th, 2024. Foundational research, also known as basic or fundamental research, uncovers the core concepts for a field of study. It is primarily driven by a desire to expand knowledge. Findings from this work often provide the groundwork for future applied research, which seeks to solve specific problems or create new products and technologies. UNC Chapel Hill biologist Bob Duronio said it best in a 2018 article. It begins with curiosity about a process, and then a question about that process, and then a hypothesis that will lead to an experiment that will provide results and data to interpret. What I love about this process is that my hypotheses are often wrong, and that's really exciting. The excitement of foundational research is fueling this year's University Research Week, a campus-wide celebration of Carolina's research prowess and an effort to engage undergraduate students in research. Themed back to basics, this week-long series of events will highlight the power of fundamental research and its real-world impacts across many disciplines. 3 undergraduate students working on foundational research projects share how that drive for discovery fuels their inspirations, failures, and lessons learned. Golden chemistry opportunities. Anna Vu is a senior majoring in chemistry within the UNC College of Arts and Sciences. Describe your research in 5 words. Changing microenvironments for sustainable solutions. How did you get involved in research? As a first-year student, I came across an email on the chemistry majors listserv from Matthew Lockett, who was looking for undergraduate students interested in researching renewable energy via surface analysis, a technique for discovering the chemical structure of a material's surface. This helps us understand a material's function and improves how we use it going forward. This opportunity piqued my interest because I wanted to conduct sustainable research but wasn't sure how chemistry could be used in renewable energy projects. I started working in the lab as an undergraduate research assistant at the beginning of my sophomore year and have been ever since. Tell us about your research. Through my research project, I use electrochemical techniques and surface analysis to study the electrostatic interactions between ferrocene molecules attached to golden surfaces with different textures. Ferrocene is a type of chemical called an organometallic compound, which means it has a bond between a metal atom and an organic molecule. I hypothesize that as the roughness of a gold surface increases, the interactions between molecules will become more negative and repulsive due to molecules becoming more disordered and closer to one another on a textured surface. Using ferrocene and a high electrically conducted surface like gold allows me to build a model system and can aid our understanding of more complex chemical interactions. These processes can be used for artificial photosynthesis by converting solar energy and small molecules like carbon dioxide into energy-rich products like environmentally friendly liquid fuels. Tell us about a research challenge that you faced and how you overcame it. When I was just getting into research, I would attach a lot of emotions to the outcomes of my experiments, especially when they took a lot of hard work and effort. Whenever an experiment failed, I would often blame myself. As I gained more experience, I came to understand experiments frequently failed due to external factors. This realization helped me detach my emotions from my research and not associate my self-worth to their outcome. Failure is completely normal and valid in science, so learning how to deal with it allowed me to gain a deeper understanding of my subject and make more progress in my project. Finding independence through Dutch history. Sophie von Dine is a senior double majoring in peace, war, and defense and communication studies within the UNC College of Arts and Sciences. Describe your research in 5 words. Illuminating Dutch independence and sovereignty. How did you get involved in research? My family is Dutch, and so I've always been fascinated with Dutch history. After searching for research opportunities, I found UNC's Summer Undergraduate Research Fellowship, SURF, program, which provides funding for students to design and carry out a research project on a topic of their choice. This program immediately grabbed my attention because it allowed me to study an interest of mine, the 80 Years of War, 1568 to 1648. This is when the Netherlands fought for independence from Spain, which led to the formation of the United Provinces of the Netherlands, also known as the Dutch Republic. Tell us about your research. My research focuses on how state sovereignty, the idea that the state has ultimate political power, emerged between 1500 and 1648 in the Netherlands, as compared to the rest of Europe. State sovereignty is the idea that the state is not answerable to any higher power and is theorized to have emerged in Europe around 1648. The Netherlands is often left out of this narrative, despite the clear Dutch impact on early modern Europe, leading to an incomplete picture of how state sovereignty came to be. My project shows how the Netherlands became sovereign during this time frame and puts the Dutch in conversation with the rest of early modern Europe. Tell us about a research challenge that you've faced and how you overcame it. Writing my research proposal was one of the hardest parts of my research. I'd written a research paper before, but I'd never written a proposal. My advisor, Wayne Lee, helped me make sense of what he called research's catch-22. You can't write the proposal until you know what you hope to gain through your research. But without having done the research, you don't know what you will find. He helped me figure out how to do enough background research to write a thought-out proposal while acknowledging that my final product could be very different from what I originally proposed. In sync with physics research. Advait Cheruvu is a sophomore majoring in computer science within the UNC College of Arts and Sciences. Describe your research in 5 words. Exploring properties of quantum particles. How did you get involved in research? I developed my interest in physics from my dad, who introduced me to the basic physics principles from an early age. When I was in high school, I made the transition to try to understand quantum physics, how nature behaves at an atomic level. Quantum particles have very strange properties, and that's what drew me in. There's a property called superposition, where a particle can be in multiple states at once. It felt a lot like magic to me when I was first learning about it. Objects can pass through walls and can be in 2 places at once. When I came to UNC and met Professor Catherine Newhall and NC State's Alexander Kemper, I began to learn more about quantum physics and its applications in computing. These models help me understand what happens to quantum particles, electrons, protons, neutrons, and photons, as they change in state over time. One interesting behavior of these particles is quantum synchrony, where the states of multiple quantum particles can become synchronized or anti-synchronized with each other. This inspired me to begin researching this property and its potential applications. Tell us about your research in a few sentences. My research deals with why and how quantum particles synchronize. Certain conditions can create synchrony where, as the particles evolve, their states change in phase and completely out of phase with each other. An analogy for describing this phenomenon is to picture 2 pendulums on a platform. When you start swinging the pendulums in random positions, they swing out of sync with each other. But over time, they synchronize. My goal is to determine the conditions that create synchrony, which can have impactful applications. For example, I'm exploring how a synchronizing quantum system can simulate two synchronized stock prices by using quantum computing. You can figure out how the stock changes over time, and you can use synchrony to assess which stocks rise and fall in price. Tell us about a research challenge that you faced and how you overcame it. The Lindblad-Master equation describes how quantum systems exposed to external energy evolve, but to do so, it uses a matrix, a table of numbers that represents a mathematical property, rather than a vector, a geometric object showing length and direction, which I was more familiar with. Translating between these different ways to represent quantum systems was a struggle, especially since I didn't understand why a matrix was used. After talking with my advisor, I found a simple formula to convert the vector form of the system to the matrix form. I later learned that the matrix form had more useful information about the quantum state that could not be conveyed in the vector form. Asking for help when you don't understand something is extremely important, and in my case, helped me avoid future misunderstandings about an important concept.